Okay, we're going to do a first run through. Alright. Okay, these are A1, A2, B1, B2. Put everything down. And power switch. This is just making sure everything is properly running. I'm almost set up to do the C of P efficiency experiments, but not yet. I got to get the batteries in a proper state to start with, because right now the voltages are off. This one is 11.05, this one is 12.27, B1 is 12.51, and B2 is 12.56. So they're not set up yet to function properly, but I do have it set so that in the up position, A1 and A2 are wired in series, B1 and B2 are wired in parallel. So we have 24 volts powering this motor that's going into B bank 12 volts. But until I get them properly set where these are both higher voltage than these, which means the B batteries, I have to drain them a little bit, because right now you're not going to get a consistent reading. But I'm almost ready to do the C of P testing. The biggest headache was getting these connections set properly, and I discovered that I couldn't put the power on-off switch over here between the input power from switch 3 and the emitter of the transistor. Because before, when I had it over there, when I put these switches down, the minute I hit one of these outside switches, the motor would kick on, even without this being down. So that wasn't working. It took me a bit just to get the wiring set so that this would run properly. Also with this diode, I had to flip that diode because the way it was laid out in the circuit diagram, this thing is backwards. So anyway, the biggest problem was just getting to this point. But at least now everything is running. So just going to show now how to flip it to go the other way. Power off. Pull these. Pull these. Going down. Down. So now in the down position, we have B1 and B2 in series, feeding 24 volts through the motor into A1 and A2, which are now in parallel 12 volts. And since the B batteries are both higher voltage than these two, this is shown properly, that these are draining a little bit and they're charging these. But what I got to do next is run these B batteries down a little bit so that I can do a proper efficiency test. But just making a major step, just having this set up now so I can do the testing. One other important point, the coefficient of performance efficiency testing, what I'm doing is copying the methods used by the Bedini Monopole 3 group. They were testing the Bedini motors, getting the efficiency, and I'm going to use their model. In fact, they used 12 volt 4 to 7 amp hour batteries to test. Mm-hmm. Being careful not to touch any of the exposed metal of the Frankenstein type knife switches. But at least these are properly showing, and I'll get back to it and do it more in detail. Once I have these set to do the test, it'll take about 2 or 3 days to do the full efficiency test. And that's whether or not I have this wheel properly near the reed switch. But so far so good. One thing I will say is that as opposed to the Benitez motor, the voltages don't move as rapidly as they did with the Benitez motor. I mean, the run batteries, the drain isn't as quick as with the Benitez. And that's important because the CFP experiments are going to require me to run this thing for like 12 hours at a time to get a proper efficiency measurement. But so far so good.